So, Dr. Goswami, let's talk about our potency of our stem cells because many people feel like, oh, I'm too old or I'm just not healthy enough. Can somebody in their 50s, 60s, 70s, 80s, even 90s be able to bank their own stem cells?
Absolutely. That is the beauty of stem cells. As we age, number of stem cells do tend to go down, but the potency and the effectiveness of stem cells stays the same. That's how mankind has lived beyond 100 years. In
Hmm.
fact, there is evidence of people having lived to 150 years too.
Yes.
And part of the reason is because the stem cell potency stays the same. The number goes down. And that's why I think the most significant development in the world of stem cells is stem cell banking, the ability for you to bank your stem cells so they can be culture grown in the future or anytime you need a treatment into millions of stem cells. So the number part is addressed, through
Right.
stem cell banking.
And I can see that's where medicine is going to be going. The advancements of medicine is to be able to bank your own cells, no matter what age you are, and to be able to have the opportunity for the reputable labs to be
Yeah.
able to cultivate your cells to a higher number. Because as we get older, the number of stem cells in our body significantly declines. However, you're telling me that the
Yeah.
potency is still there. A stem cell is a stem
Having
cell.
said that, we don't know what the dose of stem cells really is, right? We haven't progressed to that level where we, like with the tablets, we know we can say, hey, you need to take this tablet twice a day, three times a day, or,
Right.
whatever times, and 10 milligrams or 50 milligrams. So I can't say that, okay, this patient needs 200 million stem cells and this, but we know that the application of stem cells is going to mushroom in the coming years. And especially with the work the Japanese are doing now, where they can actually take your own adult stem cell, provided you have one
Mhm.
available to them, and walk it back to a more immature stage. Because one of the
Mm.
knock on adult stem cells is that by the time we become an adult, the stem cells have matured, right?
Mhm.
They our liver cells are going to produce liver stem cells are going to produce liver cells, kidney stem cells, kidney cells, similarly with our muscle and every organ.
Right.
So what if we need stem cells, say, for nerve damage or paralysis or
Mhm.
some other condition? So the Japanese are working on technology which can take your adult stem cell and walk it back in a
Wow.
laboratory to a more immature stage and then
Mhm.
stimulate it to grow into the kind of tissue you need. And how
Mm.
cool would that be? But it's still your own stem cell. So your
Right.
DNA and the basic structure of the cell doesn't change. It's just
Mhm.
that you're able to generate so many different kind of stem cells for yourself, to
Right.
which I mean, it's just going to
That's
be
that's
amazing
amazing.
where
So
the
I can like
science is
grow a
going
new
to.
kidney or a new liver?
Absolutely, and
Wow.
our understanding, and you again touched a topic that's very near and dear to my heart in further research, and I wrote a white paper on it a few years back
Mm.
on called organogenesis, right? So what is
Mm.
an organ, right? When we think about right now, organ transplant,
Mhm.
it's fraught with so many challenges, right? First, finding an organ. So say somebody needs a kidney
Mhm.
and we go around looking for a kidney from a donor, then we have to match it,
Right.
then we have to give patients so many immunosuppressive drugs.
Yep.
Lots of time it's not the transplant itself that
Mhm.
causes the morbidity and mortality that comes in these patients. It is the drugs that are used to suppress the immune response to that foreign
I can
organ.
see that.
But what is a kidney or a liver at the end of the day? It's a collection of cells that performs a certain function. So
Correct.
in the future, when we are able to culture grow your cells into kidney cells, we may
Mhm.
not necessarily need an organ like a kidney, right? We could put those cells into a biocassette and just
Mhm.
slip it underneath your skin and let your body blood vessels grow into it, and then those cells will
Mm.
perform the function of the kidneys,
Wow.
right?
Wow.
Does
It's
that make
very
yeah? I,
futuristic.
I hope I'm being
Woo.
able to explain it, but that's the most exciting part I find of
Mhm.
of where we are headed. We can't overemphasize the importance of banking your own stem cells because you're opening up, then you open yourself up to all of these possibilities with
Mm.
the most potent force, which is your own stem cell.
So you want to be able to bank your cells now. to be able to have a wide range of opportunity into the future, because this is a fast growing
Yeah.
advancement in medicine. If you bank your cells today, it's one simple procedure, goes off to the bank. When you need those cells for whatever ailment that you have, it's 4 to 6 weeks. They culture these cells to increase the number no matter what age you are. Remember, the viability of that cell is good, but it increases substantially the number and gets back re-injected into me. So I can do this 4 to 6 weeks from now, or I can have my cells banked 10 years from now, and call the lab up and get another dose of cells. Or even with medical technology, like you had mentioned, the Japanese being able to bring the stem cell back to an earlier generation. We can even create kidneys, livers, whatever,
Yes,
20,
absolutely.
25 years from now. So that's really exciting. And that's why
It'll be
it's so
actually a lot
important.
sooner. You'll be surprised. These changes are going to happen much, much before the first man lands on Mars.
Wow.
So, you know,
Wow.
it's my challenge to Elon Musk.
Elon, bring it on.